Good day and welcome to this video in our series teaching C#.NET for engineers. In this video we are going to continue from the previous video in which we introduced C# classes conceptually. In this video we are going to look at a hands-on example of building a somewhat useful C# class. The objective that we are going to set for ourselves to do in this example is to build a class that can take an array of numbers and then return standard descriptive statistics such as maximum, minimum, range, mean and median, and standard deviation. So let's just look at where we are going to put this class in our C# solution. So these are the two projects that we created in the earlier videos in this series, and we are going to create this class inside of the library project, and we are going to put it in the math operations or math ops namespace, and we are going to call it Descriptive Statistics. Now I just want to warn you that there is a Descriptive Statistics class that is available in .NET. So if you are going to write some sort of a production application, you may want to rather make use of that. But for illustrating the principles of building a useful class in C#, we are going to build our own, even though we will only put very basic features into it. Okay, so let's head over to Visual Studio and start building our class. So here I'm going to open up the solution that we created earlier. I still have the last example in here. I'm just going to leave that for now. I'm going to close all of these other classes that I had open from the previous example. And then I'm going to go into my Solution Explorer, and there's my two projects. I'm going to put it in the library project, and as I showed earlier, we are going to put this class in math operations. And now we are going to name this class properly. Previously I pointed out that you will never name classes like class 4, class 5, but always give a much more descriptive name. Now notice that when we put a new class in the math ops names folder, we are basically automatically putting it under the same namespace. In the previous video we explained how namespaces map to subfolders in Visual Studio. So I'm going to right click, I'm going to say add class, and I'm now asked to provide a name for this class. So I'm going to call this Descriptive, like that. I notice I use camel case. It's good practice to start class names with a capital letter and not put any hyphens or underscores in them. So I'm going to do that, and you can see now there's a file. If you go and look on Windows Explorer, you'll see in this folder there is a physical file there. As a matter of fact, let's go and do that. If you right click on the folder, you can go in Visual Studio and say open folder in File Explorer, and there is the folder in File Explorer. You can see there's my demos folder under my C drive. I've got my library, I've got the math ops subfolder, and there is the physical file that I've just created. Okay, now here is this file. If I click on it, it will open for me in the editor, and you can see the namespace has already been added, and the name of the class matches the name of the file. Now in my Visual Studio automatically puts a modifier called internal in front of the class. In the previous video we explained what these modifiers mean. I want to make this class public, so I'm going to change that to public lowercase, and also I want to not use these curly brackets around my class for the namespace, and I showed in one of the beginning videos that we can just put a semicolon at the end of that, and then Visual Studio will remove those brackets, and my class will be under that namespace automatically. Okay, so now what we want to do, we want to give this class a set of numbers, an array of numbers. And I'm going to make use of one of the object types in .NET called a list. And I'm going to pass a list of numbers, double precision numbers, that I will call data. And then I want to calculate the minimum, the maximum, and let's start off with calculating just the minimum, the maximum, and the mean. Now, first off, I'm going to show you the way a wrong, or let's say a non-optimal way of coding this. And then after I've done that, we will discuss why it's not optimal, and then we will improve the class to be a little bit more optimally coded. So let's say the first thing we want to do is we want to create a method that calculates the statistics, and that method must take in a list of double precision numbers. So I'm going to make this method that takes in the numbers, I'm going to make that method a public method, so that with the class, any projects that I create can make use of this class and that can make use of this method. And let's say I'm going to create one method to calculate the maximum, I'm going to use another method to calculate the minimum, and another method to calculate the average, right? Now I'm going to be showing you some C# syntax now. And this will be a little bit as if you've just landed in Paris, France, as I said earlier, and you don't know how to speak the language, and I'm the translator, and I suddenly start talking on your behalf to a shopkeeper in French, and you don't quite know what I'm saying. But you have to just repeat it, and if you do it enough, it will become natural. So don't be put off by the strange syntax of curly braces, etc. that you're going to see now. Over time, this will become more and more familiar, and you don't really have to memorize it initially. You can ask ChatGPT to help you with any of the syntax, and over time you will start learning it. So just remain confident that over time it will come. So I'm going to write a method now. I'm going to make it a public method, and this method is going to return a double precision number. You can see my GitHub Copilot is already creating for me a property there. It's not a method. I'll just explain properties in a little while. And I'm going to make this double, and I'll call it maximum. And I'm going to pass in here as a parameter a list of double, which I call data. And you can see that my GitHub Copilot has automatically said, well, since this is a list of double, there's already a method on it called maximum, and you probably just want to return that. Now that's true, but we want to learn. So I'm going to write a loop now to actually calculate it manually. It's not optimal. This is a very good way of doing it if you're going to do this in production, but let's see how we would do it. So first of all, I'm going to create a double max variable that I call maximum, and I'm going to set this value to a very small value, and I'm going to use double minimum, the minimum value that a double can take, which is a very, very small value. And now I'm going to loop over each data item, and I'm going to not use a for each loop. I'm going to use something a bit more basic, and I'm going to use for I equals 0 to I equals data count. And again, this is now syntax, so it will be strange to you exactly how this works, but basically I'm looping from the index 0 up to the index that is just less than the number of items data.count in data. And I'm going to extract the value now, and that value is double value equals data.I. So I'm getting the value from the array index at a position I. Now notice, I will say this many times in this course, that in C# arrays and lists are zero index. So the first index, the first item in an array or a list does not start at the index 1 like Visual Basic does. It starts at the index 0. So the last item is always going to be one less than the number of items in that list or array. So if you've got 9 items in an array, the index of the last item is going to be 8. And that's the reason why I've got a less than and not a less than and equal to sign here in my for loop statement. So now I'm looping over all the values in data. I'm extracting the current value, and I want to see, is that value bigger than than maximum? If it is, then I want to update maximum. Now maximum is currently the minimum value of a double precision number that is allowed for in .NET. And you can see there it is indeed a very, very small number. So the chances of your data containing a number smaller than that as its maximum is very, very unlikely. So then now I'm just going to say if value is bigger than maximum, then I want you to update maximum to value, right? So I'm basically I'm setting maximum to a very small value. Now I'm looping into the first value. If that value is bigger than maximum, then set maximum to that value. Then I go to the next value. If that value is bigger than maximum, then I update maximum. And I keep on doing that. Once I get to values that are lower, maximum is no longer going to change, and I will find the maximum value in the list. You'll see there's a red line here because it says you are not returning a value. I have to return a double value, and I'm not doing that. So now that I've calculated it, I can just say return maximum. So now I've got the maximum, and now what I'm going to do is I'm just going to calculate the minimum in the same way. So I'm going to write another method here called double minimum, and you can see my GitHub Copilot has basically sensed that that's what I'm going to do. The only difference in this loop is that now I'm using the minimum and I start off with double maximum value. So I'm picking a very high value, and then I'm looking, is my data lower than that? It's very likely to be the case. Then I move it lower. I look at the next one, is that lower? And so on until I find in that way the minimum value, right? And now let's go one up and we calculate the mean. You can see my GitHub Copilot is suggesting that for me, and I have got now a method there to calculate the mean. So notice how I do this. I set the sum, and then I loop over all my values and I update the sum with the current data value. Now that plus equal is the same as if I am saying sum equals to sum plus data I, right? So that is a C# shortcut. This statement here is a C# shortcut for this statement, plus equal. So just because we are just starting to learn, I'm going to use the more declarative way of writing it. So I'm calculating. All of you know that the average of a list of numbers is the sum of all the numbers divided by the number of observations. That gives me the mean. And that's basically what this little for loop does here, right? So now let's go and test this class now in our console application. And the way we are going to do that, I'm going to first go and I'll open Excel. And in Excel, I'm just going to enter a range of numbers. I'm just going to put in a few numbers like that. I'm just going to use data analysis, random number generation. I will use a normal distribution. I want only one variable returned. I'm going to say a mean of 8 with a standard deviation of 2. And I'm going to put this data in here. I'll just do a small array of data and I'm going to say okay. So there I've got some numbers generated. And now what I want to do is to put these numbers in an array or in a list of doubles that I'm going to pass to my Descriptive Statistics class. Now to put this in a list of double, I can go and type this out in C#, right? But it's very cumbersome. So I would rather just copy this and ask ChatGPT to do it for me. So let's go and see. Remember at the start of this course, we said that this is 2025. If you are going to do any type of coding, most likely you are going to be making use of ChatGPT, and it's my objective to teach you how to do that optimally. And this is a typical example. You don't want to go and sit and type all of these numbers in one by one. You can just let the robot do it for you. So I'm going to copy these numbers and I'm going to go over and open ChatGPT. Okay, so here I'm in ChatGPT, and this is the way I would typically put this prompt. I would say in C#.net use the following, and now I put Shift Enter and I paste all my numbers and I press Enter. Right now you can see here ChatGPT is being a little bit cheeky because it's generating for me a whole program with those numbers, but all I actually want is this list here. Right, so that's all I want. So I'm just going to mark that in my browser, and I'm going to go Control C. Right, so I've marked that and I pressed Control C. Now I go back to my Visual Studio, and I'm going to go back here, right here to my application, and I go to my program class. And this is what I had last time. I'm going to delete everything except that last line there. And I'm going to go Control V. So I'm copying now from ChatGPT. And now I'm going to go and create an instance of this class, Descriptive Statistics. And that is like an object that we are creating in C#.net, which is an object-oriented language. So I'm creating a descriptive statistics object, and I can do that even though I'm no longer in my library. I'm working in my app, in the My App project. Because this class is public, I can now call any of these methods. Right, so there's my list of data, and now I'm going to create a descriptive statistics, and you can see Visual Studio says to me there, I don't know where this is, and that's because I haven't put a using at the top to say that I want to use this library and namespace. So I can go and type that at the top, but you will see Visual Studio, if you press Control dot, it will pick that up, and you can just click on that, and it is going double click on that, and it will put that using statement for you at the top. So now I've got this object. Remember I said earlier that when you initialize a class, you almost use the new keyword, and you put the name of the class with open brackets behind it. Sometimes the class will have to be initialized with some parameters. We'll come to that later. So now I've got my stats object, and now I can go and say double min equals stats.minimum, and we pass the data. And we can put console right line minimum, and we put min. That's all syntax that we had in earlier examples. And I'm going to do the same with max, double max. And there I'm calling into the maximum method. So I'm calling into this method, and then I can put again console right line maximum, and then I put double mean. So I'm getting another value back, which is the mean of the data, and I put console right line mean. Right, so let's go, and I'm just going to go over to Excel, and I'm going to calculate this quickly in Excel. Maximum of these numbers, 11 equals minimum of these numbers, and I'm going to say equal average of these numbers. In Excel we use average and not mean. Alright, so see, I've got 11.58 as a maximum, I've got 5.22 as a minimum, and I got 7.75 as a mean value. So let's go and run this in the console application. So I've got a minimum here of 5.22, etc. I've got maximum of 11.58, and I've got my average of 7.75169, etc. Right? So that is a sort of a test, and typically you will write in C# a unit test to test that number and to store this test so that you can reuse it later on if you change something in your code. You can always rerun this test to confirm that your method is still working. But we'll probably get to unit tests later in the series. For now, that's just the way that we are going to code it. I'm going to just press enter and close that down. So that now we've seen how we've written our class. Remember, we've got our using statements at the top, then we've got our namespace, then we've got our class, and that's basically the class, and in our curly braces we've got all the methods in the class. Now this is not a very effective way of doing it, and I'm sure that I may have some people commenting on that because it is not at all an optimal way. Why is that? Because notice that all of these for loops are very similar. Each time I loop over the data to get the maximum and the minimum and the mean, etc. Right? So that means if I have 1,000,000 data points in this data array, which can easily happen, and I'm going to call minimum, or I'm going to loop over 1,000,000 values in the data. If I calculate the maximum, I'm going to loop again, etc. But notice the data has not changed. Maybe I've got these statements may be in a loop themselves, and so I'm going to recalculate these values all the time, which is really unnecessary because I only have to recalculate it if my data actually changes. So if I go back to my descriptive statistics class, let's see how we can improve on that. So the first thing that we are going to do is we are going to generalize this loop, which is so similar, and we are going to calculate all of the values that we may want to get from that single loop. So I'm going to call that loop public, and I'm going to make it void, which means this method does not return any values, right? This is just a method that calculates things, and I'm going to call this calculate. And I'm going to give this, and I'm going to give this also a list of double, right? And then I'm going to take this loop here, and I'm going to cut this, and I'll put it in there. So there I'm calculating my maximum, and then all I have to do is to take this value out and put it in there, and also the sum, calculate that and put it in there. And now I have to, so there's no return value coming from this method, and I'm going to take this and put it in there. I'll go back to this in a second. I'll put that in there, and I'll explain this in a second. And what I'm going to do now is to say double mean is equal to sum divided by data count. And now I can delete these methods here. So I've only got one method, which is calculate. I give it my list of data, and these values are automatically calculated. But now, how do I get these calculated values? Now they are calculated in a single loop, right? So if I call this method calculate once on this class, it will automatically calculate my minimum, my maximum, and my mean for me in one single loop. So it's now much more effective than it was earlier. However, how do we get the minimum, maximum, etc. out of this class, right? Now this is where our modifiers come in. So what we can do is we can declare a variable at the top here. So I'm going to declare that as private. Now remember, in the previous video we said a private variable is only visible in the class. So I'm going to call this private double, and I put an underscore next to it, and then a minimum. Now that underscore is just a convention. Not all programmers like to use it, but I've grown sort of used to it over time. So that then I know that any variable with an underscore is a private level variable inside the class. Now because it's private, I can access that variable anywhere inside the class, but not outside the class. Whereas a variable that's declared inside a method, like this is my method calculate, and I've got a variable maximum declared there, I cannot access that variable outside of this method. So that's called local scope. So it's just locally available, that variable maximum, and also the variable minimum and also the variable mean. But the one called underscore minimum, that is visible everywhere inside the class. So once I've gone through all of these calculations, I can now set this value, right? And I'm going to also declare a maximum and a mean, and all three of them have the underscore in front. And now that I've calculated this, I can just set those private variables. Maximum is maximum, minimum is minimum, and mean is equal to the mean value. So now I've got these variables set. So if I go back to program, we'll see now I've got a red line here because I don't have access, I no longer have access to that minimum method and the maximum and the mean. So I still need to expose them because they are currently held in these private variables, and I'm not making them available to any program that accesses this descriptive statistics class. So now what I can do is I can write again my method public double minimum. I don't have to pass the list of data in here. I can just say return underscore minimum, right? And I can do the same with my maximum, and I can do the same with my mean. Normally, if you write a method that returns a value, I like to put get in front of it so that you clearly understand that this method is returning a value. Unlike this one, which just has a verb like calculate, right? Which returns void. In other words, it does not return anything. So now, if I go back to program, you can see my names are not correct, so I'm going to just put get in front, and it no longer requires me to set the data. I'm going to change that, and I'm going to change that. And notice that we haven't yet called this calculate method on our data. So first thing we have to do is to say stats.calculate data. Okay, so let's go and just run this, but before we do that, I see there's an error here. This is the maximum, so this should be get maximum, and this should be get mean. Right? So I run that, and there I've got the same answers. Now I've improved this. Now because I'm only looping through my data once, right? But however, this is not really good practice because I've written a method that says get minimum, which sort of indicates that something is being done in that method. However, I'm just returning a variable value. So I'm taking this private variable here, and I'm exposing it publicly using this method. Now, a better way to do that is to use what's known as properties. And in the previous videos, I said that properties you would normally put at the top of the class. So I'm going to say public double minimum. And you can see that my GitHub Copilot has automatically completed that for me. And this is the way that a property or a variable can be exposed publicly, but in a very controlled way. Because in this object declaration, in this property declaration, I have only a get clause or a get component. I don't have a set component. So I can get the value for minimum, but I cannot set it. And that's what we want. We don't want someone else to say, hey, after you've run calculate, just change minimum to 0. You want it to be encapsulated. So encapsulation is one of the principles of object-oriented programming. So there's a difference between this type of code and this one here. This is called a method, or it maps to a function in Fortran or Visual Basic. but here it's a method, and this is what's called a property. And I like to put the properties at the top of the class like that. So let's go and write similar properties which will then expose these private variables to the outside world. So I'm going to create a maximum which will return maximum, and I'm going to return a mean which will return a mean. Right, and then I can remove these functions like that, and now my class is much better structured because I only have one calculate function here, and I'm calculating my 3 statistical properties, but I have got them encapsulated so nobody can mess with the minimum, maximum and mean values. The only way that you can change that is if you pass in a new set of data into the class. So in that way we've encapsulated the data now, and we've encapsulated our variables. Now this is a very small class. You can see everything can be seen here on a single screen, and so it's quite easy to understand what's going on. But when your class starts to grow, sometimes these methods will have more code in them, and you may have 10 or 20 variables in a class. It's a bit more difficult to quickly see certain components of your class. So what I like to do is to use the feature in Visual Studio called regions, and to create a region you type the hash key and you just type in region, and then you have to end region, so hash key end region, right? And I can do the same here, region properties. Sorry, I had to put here variables. So that's a region called variables. I've got one for properties, put hash end region, and here I'm going to have a region called for methods, and I have to put a hash end region at the end. So if I go and collapse these regions, you can see how tidy my code looks. I use the spacing, so this is very neat. If I know I want to go and look at my methods, I just open this and I can collapse any of these classes, and my code will be very neat in that way, and much more easily mentally to navigate and manipulate your code in that way. So I'm going to just save this now. I'm going to go to program, and now I no longer call the method, I'm just calling the property. So I can take this get away like that, and because it's not a method, I don't need these brackets at the end, so I just call it like that. And now my class is much neater. I'm just going to collapse this data here, run it one last time, and there are the answers for my descriptive statistics class. Now something that you can do for homework is to try to ask ChatGPT to help you to expand this calculation to calculate the median value at the same time. So we've calculated minimum, maximum and mean, so you can add a median value using this same type of pattern where you declare these private variables, you set them in the calculate method, and you then expose those values using properties as we've shown here, right? So that is a good exercise for you to do in homework. Now the one thing I just want to point out, that this class, although it's improved from the previous version that the first version that we made, because we're only looping over the data once, there is still a flaw in this, because if I don't do this calculate, if I create my object here and I forget to call its calculate method, so I'll just comment that out, then these values will be wrong, right? And so you can see if I run that, I just get zeros, right? Because the calculation wasn't done, and so it's returning the default values associated with these. So a good idea would be to put some sort of a flag or a Boolean variable, a true-false variable here, and to only set that variable if this routine has run, and then to throw an error or create a warning of some sort if I'm trying to get the minimum before I've run this calculation method. That is also something that you can try as an exercise, but as we go into more practical and realistic examples later in this course, we will show you how that is typically done. For now, you should have a fairly good idea of how a class in C# is typically structured. You can see why these modifiers like public and private, why they are important, and you can see how you can create a class in a library and make use of it in your executable program. So that's it in this class. In the next video we will discuss some useful C# objects such as lists and dictionaries. You've already run into lists in this example, and that is what I think we will do in the next video. So that's it for this video. Thanks for watching.